Greetings, my young Padawans. Today we are going to explore the world of scientific notation. Now, scientific notation is going to be very helpful to us whenever we're dealing with extremely large numbers or extremely small numbers. And we will frequently run into them in science, engineering, but also in things like probability and other where you're considering the possibilities of an event occurring. Sometimes those numbers get incredibly small. So I'm going to now present to you some ideas about scientific notation and cover some ways to work through some of the problems you're going to encounter in class tomorrow. Scientific notation is useful whether you're dealing with something very big like the planet Saturn, which is gigantic, or whether you're dealing with something small like, say, a paramecium, which is very tiny. So, in either event, whether we're dealing with something incredibly large or incredibly small, scientific notation just simply makes life easier. So, what is this scientific notation that we're talking about? A number is expressed in scientific notation when it is in the form a times 10 to the nth, where a is between 1 and 10 and n is an integer. Let's take a look at the mass of Saturn. It's huge. This is a gigantic planet, one of those gigantic gas planets. Not as full of gas as some of you, but still pretty daggone wide. And the mass is unbelievable. Look at all those zeros. We're talking 0 after 0 after 0 after 0 after 0. Gigantic. Look at all the space it would take if we had to represent it that way every single time. On the other hand, a paramecium is very small. 0.0000364 meters wide. That is very tiny. Now, we can express the size of that paramecium as in scientific notation. And when we do, we have to move the decimal. And we're going to slide the decimal over to the right until it's between the 3 and the 6. Now, we move the decimal how many places? You count. How many places? 1, 2, 3, 4, 5, 6. So we counted at 6. So when this number that is less than 1, where we had to move the decimal 6 places, would be expressed as 3.64 times 10 to the negative 6th. Now, if we wanted to express a number such as 1.4 times 10 to the negative 4 in decimal notation, we take the 1.4 and we move the decimal 4 places to the left. And we end up with 0.00014. Now, see if you can get from 5.27 times 10 to the 6 and scientific notation into its proper decimal notation. If you're doing this on the graphing calculator, the notation is done with the EXP button. You could type this problem in as 5.27, then hit the EXP button and hit 6. It will then deliver to you the decimal notation. Now try a calculator to solve this problem. 7.2 times 10 to the negative 9th over 1.2 times 10 to the 2nd. Now when we put this in the calculator, we're going to get 6 period e to the negative 11th. In scientific notation, that's the same thing as 6 times 10 to the negative 11th. And the answer in decimal notation is, got a lot of zeros. Now let's take a look at using the calculator to evaluate this expression. We type in 4.5 exp negative 5 divided by 1.6 exp negative 2. If you don't use those buttons, if you decide to not do that, then you've got to start typing in a whole bunch of parentheses. So those buttons are going to make your life a lot easier. So as you can see there in scientific notation, the correct answer to the problem is going to be 2.8125 times 10 to the negative 3rd. Now, let's take a look at this one. Okay, use a calculator to evaluate 3, wow, 600,000,000 times 23. The answer comes out at 8.28e plus 10. In scientific notation, that's 8.28 times 10 to the 10th. And you can see the decimal notation there has a lot of zeros. Now, try the next problem with a calculator. Sorry about the shadow, late in the day. When you plug these two numbers into your calculator, you end up with this. That's a good decimal notation. But what about in scientific notation? 1, 2, 3. We have to move 1, 2, 3, so we end up with 10 to the third. Now, this one, slight different challenge. Write in proper scientific notation. Notice here we have a number, 234, that's not between 1 and 10. So that is not a proper scientific notation. So in this case, we have to move 1, 2 decimal places. We started with 9. We add the 2 that we moved, the 1, 2, to the 9, and we get 11. So our correct scientific notation for this form is 2.346 times 10 to the 11th. Now, why don't you go ahead and try to work problems A. Give yourself a second, pause, give yourself a second, and work problem A. Okay, I hope you got answer number 3. Now, give yourself a chance to answer problem B. And on B, I certainly hope you ended up getting answer number 2. And C. A little bit longer problem. And for C, I certainly hope that you ended up with answer choice number 6. Okay, so I hope that helped you understand scientific notation, and I look forward to seeing you in class tomorrow so that we can work on these problems together. But as for now,